Now let us try to study let us try to find out relationship between conservative forces and potential energy. Now we know that the spring force and the gravitational force, they are conservative forces, and the spring potential energy is given by half kx squared, and the gravitational potential energy is given by mgy. And we also know that the work done by the spring force is given by half kxi squared minus half kxf squared. So it will be u spring I minus u spring f, which will be equal to minus delta us. So this will be the work done by the spring force. In the similar manner, the work done by the gravitational force is given by mgyi minus mgyf. So it will be minus delta ug. So we can generalize this and we can say that the work done by an internal force, because these two forces, they are internal to the system. So we can say that the work done by these internal forces is equal to the change in their respective potential energies in each case. So we can generalize and we can say this about the internal forces. So now if we have to find out work done, then in general you know that work done is given by F vector dot dr vector. This is a general relation and it can be used for calculating any kind of work done. Okay, so it means that we can use this here also, and we can say that the work done will be F vector dot dr vector will be equal to minus delta u. So it can also be written as integral of f vector dot dr vector, and we can take this negative towards the other side, and delta u will mean uf minus ui, or uf will be equal to minus integral of f vector dot dr vector plus ui. So this is the first relation we get for conservative forces and the potential energy. Now let us take this equation again, where f vector is equal to f vector dot dr vector is equal to minus delta u. Now instead of this, we can also write, if we remove this integral, then we can write f vector dot dr vector is equal to minus du. We can write it. Okay, but let us check if it is right or not, or it is not correct. So after writing this, let us just take an integral of it, and it will be f vector dot dr vector is equal to minus du with an integral. We're just taking integral both sides, and this integral will be from the initial value to the final value, because it is on u, so maybe we can write ui to uf. So if we take an integral of it, it will be uf minus ui or minus delta u. So we conclude from here that f vector dot dr vector is equal to minus delta u. So it means that this equation, it could also be written like this, because this and this equation, you can get it by removing integral or by inserting an integral in this equation. Okay, so now let's try to solve this equation. So what we're getting from this equation is integral of f vector dot or we remove the integral and we say that F vector dot dr vector is equal to minus du. Okay. Now here dr vector is displacement, so dr is the displacement vector. So we can write it as dxi unit vector dyj unit vector plus dz k unit vector if it is moving in x, y or z direction. But if it is moving radially, then we can also keep dr and solve the problem. And f vector could also be in any direction. It could be fx, fy and fzk unit vector. So if we take this dot product and put this value here, what we'll get is fx dx plus fy dy plus fz dz is equal to minus du. Now suppose that you have force only in the x-axis, only you have x component of force, and suppose the displacement, it is also only in the x direction. So you'll have only fxi unit vector here, and you'll only have dxi unit vector. So this equation 1, it turns out to be fx dx is equal to minus du, or fx will be equal to minus du upon dx. Similarly, if it is in the y direction, then you'll only have fy dy is equal to minus du, or fy will be equal to minus du upon dy. So it just matters in what direction force and displacement are. So accordingly you get these equations. So from here we conclude that a conservative force can be found by taking a derivative of the potential energy of that force. So let us use it in spring force and gravitational force. Now we know that the spring force, let us say the spring potential energy is given by half kx squared. So if we have to find out fx, the spring force, then it will be, let us say it is the spring force, it will be minus du spring upon dx. So if we take a derivative of it, it will be minus kx. So this indeed is a spring force. So it means this relation is correct. In the similar manner, we also know the gravitational potential energy. It is mgy. So if we have to find the gravitational force, it will be minus dug upon dy. Just take a derivative of it, but with respect to y, because now potential energy is a function of y. So then it will give the gravitational force to be minus mg. Now this minus mg just means that gravitational force is always attractive. Okay, it is never repulsive. That the gravitational force is always attractive. This is what it means. So if you know the potential energy, you can get the forces.